Okay guys, so what we're going to be doing today is we are going to be talking about how we can use special right triangles with two different types of shapes, and you're going to have some word problems that have to do with these triangles. So in the notes, the first thing I do is I give you a equilateral triangle. And now with this equilateral triangle, you know in an equilateral triangle every single side is the same, but then I go a step further and I remind you that every single angle is 60 degrees. Sorry for the camera, the way it's shaking. I don't have power at my house because all my power is out at my house, so I have to go into a business to use power, and because I have to charge my phone while I'm doing this, and I am standing up in a random table at a business doing my lesson. So that's why it doesn't look this normal and everything is kind of shaking. So please forgive me with that. All right, anyways, get that out of the way. Now, with every single angle the same, I introduce you to something called an altitude. An altitude in a triangle is a straight up and down line that creates a 90-degree angle. This 90-degree angle is the height of this equilateral triangle, and it's called the altitude. Now what it actually does, it's kind of special. The reason why this altitude is kind of special is because it splits it up into two 30, 60, 90-degree triangles. Because if you have an equilateral triangle and every angle is 60 degrees, and you have an altitude, a height, that gives you an angle bisector, so it bisects this angle here and here. Now when it bisects this angle, it actually breaks it into two 30, 60, 90-degree triangles. Now this isn't that great looking of a triangle, but you get the picture. 60, 60, 30, and 30. That's what that altitude does. The reason why that's important is because, remember, in the way a 30, 60, 90-degree triangle is set up, we've gone over this extensively now. In this type of triangle, the shorter leg is twice or half the size of the hypotenuse, and the longer leg, the medium side, that's across from the 60, is the short side times root 3. Now with that, we can answer any questions that have to do with equilateral triangles. So let's take a look at the first question. It says the altitude of an equilateral triangle. Okay, let's draw that altitude. Here's your equilateral triangle right here. Here's my altitude, and it creates a 90-degree angle. Now, what do we have in an equilateral triangle? We have two 30, 60, 90-degree triangles. Now, what else does it also say about the equilateral triangle? It tells you that the altitude in the equilateral triangle is, the length of this is 5 root 3 inches. Okay, and now it wants us to find, first off, let's find the area. Well, with an equilateral triangle, you know that it splits it up into two 30, 60, 90-degree triangles. So first off, we got to find this shorter leg right here. Okay, remember, the side across from the 30 is just this side without the root 3, because this is x root 3. This side is going to be x, and this side is going to be twice that, which is 10. All right, good. Now, same thing for this. These are two identical triangles, so this side is 10 also. This is 5, making this whole side 10, 10, 10. Okay, now we have all the, I'm just going to go ahead and make this side 10. I'm so sorry about the shaking camera, but with all the power out, I can't do this at my house, so I have to make do for what it is. Thank you, distance learning, for being so awesome that we can't teach in the classroom. Okay, so with this, I have to find the area. Well, what's the formula for the area of a triangle? You know, the formula for the area of a triangle is half of the base times the height. Come on, let's figure this out down here. The base is 10, so half of 10 would be 5 times the height, which is 5 root 3. 5 times 5 root 3 is 25 root 3. Think of it as 5 times 5x, which would be 25x. Same thing. You don't mess with the root. 25 root 3, but you have to put the unit of measure. It was inches, and area is always squared. So, this is the formula for the area. All right. Now the next thing is the perimeter. What's the perimeter? Well, 10, 20, 30. 30 inches would be your perimeter. Once again, with equilateral triangles, reviewing, you have the altitude. The altitude splits this triangle into two congruent 30, 60, 90 degree triangles. Therefore, you have a hypotenuse and a short leg. This is another hypotenuse and a short leg. These two short legs is the same. Remember, the hypotenuse is twice the size of your short leg. So this short leg would be the exact same length of each one of these sides. All right. I'm going to give you another one now. I give you another example problem. I say, if you know the perimeter of an equilateral triangle. Okay, so first, equilateral triangle. What do we know about an equilateral triangle? That every single angle is 60 degrees. And it tells us the perimeter of an equilateral triangle is 24 root 5. Well, if 3 sides are the same, and all 3 sides add together to give me 24 root 5. So think of it as, instead of, let's say 3x, let's just say 3 times each side. 3 of the sides give you 24 root 5. How do we figure out what each side is? Well, divide everything by 3. And 24 divided by 3 is 8 with that root 5. All right, so you have 8 root 5. Each one of the sides is 8 root 5, 8 root 5, 8 root 5. Because remember, it told you the perimeter is 24 root 5. All right, everything is set up now. Now I can find anything else that I want. And the question that we have to find is, what is the altitude of the triangle? Okay, well, let's figure this out. The altitude of the triangle breaks it into two 30, 60, 90 degree triangles. Now what the altitude also does, it bisects this side. So it cuts the other side in half. So this is 8 root 5. That means that this should be 4 root 5. 4 root 5. Well, and that makes sense because remember, this is twice the size of your shorter leg right here. And this is your short leg. So this is what we have to find, this side, which is your short leg times root 3. Now this might look a little confusing, but we did a worksheet like this before where this was your short leg right here, and they give you a root, and it's that number times root 3. This is your short leg times root 3. So the altitude is 4 root 15. 4 root 15. That is the unit of measure for the altitude. Okay. Now we are going to talk about 45, 45, 90 degrees. ready? Now, the examples that I give you with a 45, 45, 90-degree triangle have to do with a square. Okay, look, you have a square. What do you know about a square? Well, every angle is the same, which is 90 degrees. Every side is congruent. And then if you were to draw something called a diagonal, which you should have learned last year in geometry, a diagonal is a line from one vertex angle to the other vertex angle. It bisects, means cuts in half the angles that it touches. So this becomes, if this was 90, this becomes 45, 45, 45, 45, 90. So a diagonal makes two congruent 45, 45, 90-degree triangles. All right, pretty good. Now let's review how squares are found. I'm sorry, not squares, isosceles right triangles. If this is x, this is half of that root 2, half of that root 2. Or the other way, if this is x, then this is that same number, root 2. Just depends on how they give it to you. All right, so that's pretty simple. Now, sorry, I'm actually at, if you haven't figured it out by now, the business that I'm at is a laundromat. And I don't even use a laundromat, but this business is the only business around here that has something like a table that we can enter into the business and use. And I just pretend like I'm doing laundry, but I just have, if you look, I have my notes that I'm going off of for you guys, coffee and keys and my computer. That is what happens when your house doesn't have electricity for close to 48 hours because redwood trees destroyed literally everywhere in the Santa Cruz Mountains 2 nights ago because the wind was about 45, 50 mile per hour wind and it just knocked out all the telephone poles. And Santa Cruz Mountains are a mess right now. Anyway, so that's where I am. Wonderful, wonderful laundromat. That is the business that I am at. And the table that I am using is on top of a dryer. All right, anyways, it doesn't matter though. We're still doing the same stuff as I normally would. Okay, so the first example is find the diagonal of a square. Okay, so I'm going to draw my square. Here's my diagonal. This is a 45, 45, 90. And it says the area of a square is 49. How do you find the area of a square? It's just base times height. But the base and the height are the same. So you can think of it as two sides that are squared is going to give you 49. What two numbers multiplied by themselves give me 49? Or you could square root both sides to get each side is 7. Because, look, if every single side is 7 on this square, you would know the perimeter of it, which is fine. It's 28, but that's not what it's asking. It's asking for the diagonal. Now, this is an isosceles right triangle, so I don't technically need part of this right here. I don't really need part of this. I just need that. Now, which one is this? Is it this one or is it this one? It looks like it's this one because both of these sides are numbers that they give me, whole numbers, and then this side is that same number, root 2, but it is centimeters because that's a unit of measure. So the diagonal is 7 root 2 centimeters. Okay, cool. Now, next one. Last example question. The last example question. It says find the perimeter of a square. All right. I'm going to draw my square. I'm also going to draw, I know it's going to give me something about the diagonal. And I know that every side is exactly the same. All right. And it says find the perimeter of a square actually is 16. Find the length of its diagonal. All right, this is the same kind of question. If the perimeter is 16, That means that this is 4, 4, 4, 4. This is 4 root 2. It follows this right here. That's the length of the diagonal, is 4 root 2. All right. Now, summing this up, let me just go over what I just said, and then I will end the notes. So whenever you have an equilateral triangle where every angle is 60 degrees, and you have something called an altitude, it bisects this angle. Half of 60 is 30, and it creates two 30, 60, 90 degree triangles. And the last thing that I said was a square. If you have a square and you draw a diagonal, technically this diagonal bisects this 90 degree angle, and you are given two 45 90 degree triangles. So the directions today, or the questions, you're going to have word problems, and it's going to give you the shape. I would suggest that you draw the shape out before you do anything, and then answer whatever it's asking you to solve.